Welcome to How's That Work with Mrs. Foster. I am so glad that you can join us today. We're going to go ahead and review from last time. So we're going to start with a force. Remember that a force is a push or a pull on an object. And there are different kinds of forces. We have contact forces, which is forces that act between two objects that are physically touching each other. So as you can see, we have a tennis racket, and this ball is going to come in contact with the tennis racket and then be propelled the other way. When it comes in contact, that force now is considered a contact force. We have other forces that are non-contact forces. This is a force applied to an object without having any physical contact with an object. If you watch my last video, which I'll go ahead and put up a link at the end so you can check that out if you haven't already, I gave an example of a magnetic train, and you could see how the magnets repelled or pushed each other away, or actually pushed or pulled each other closer to help move a magnetic bullet train along the track. Magnetic force is an example of a non-contact force. Okay, so non-contact forces. Again, we have three different types. We have gravitational force. That's the attraction force between all objects that have mass. You jump up, you come back down because there is gravitational force or attraction between you and the earth. We have magnetic force, the attraction force between certain metals and magnets, which we just talked about with the bullet train. And then we have electrostatic force, the attraction and repulsive force between objects due to their electrical charges. And if we go to this next slide, you can go ahead, and I've already given you some examples of gravitational and magnetic, but if we look at electrostatic force, you can see some examples like shocking someone after going down a slide, or lightning, or winter hats. When you pull that winter hat off of your head and your hair is standing up, that's because of electrostatic force. Now, we're going to go ahead and look at Sir Isaac Newton. He lived in the 1600s to 1700s, and he kind of was a do-it-all type of man. He was a physicist, a mathematician, an astronomer, philosopher, alchemist, theologian. He was very instrumental in physics. He came up with a lot of the laws and structure about things that happen in our natural world that we still use today. One of those is the law of universal gravitation. You probably know about the story about an apple falling out of the tree, hitting him on the head. That's the story behind him creating the law of universal gravitation. But he's also very famous for creating the laws of motion. There are 3 laws of motion that we still kind of base physics around, the start of physics around, and we will look at those in a later video. But I bring him up because in physics, the unit for force is the Newton, and that was named after Sir Isaac Newton. So anytime we look at forces and how strong they are, you're going to see an N or Newton behind the numbers because that's the unit we use for force. All right, so force. There's 2 things we have to consider when we're talking about force. First is the strength or magnitude, how strong the force or how weak the force is, and the direction. Where's the force going? Where's it pushing on? What direction is it going in? And a lot of times when we talk about forces, we use an arrow to show the strength and direction. The longer the arrow, the more strength it has. The shorter the arrow, the less strength it has. And the arrow will point in the direction the force is going. So let's look at this. Visual check. We have a tennis racket with a tennis ball and a ping pong ball. Look at the arrows. Look at the numbers above, okay? Now, do you remember what that N stands for? Yes, Newton. That is the unit. So we can see that the tennis racket has a force of 300 newtons. We can see the ping pong ball has 100 newtons. Now, knowing those numbers, look at the arrows. What can you tell me about the tennis racket and the ping pong ball using the information we've just learned about force and the arrows? Good. It sounds like you remember that the arrows indicate strength and direction of a force. So we can see that the tennis racket here is going to use a much stronger force than the ping pong ball. If the ping pong paddle used a sort of strength of 300 newtons, the ping pong ball would miss the table. The game would be done. But because the tennis racket and court is much larger, you need to use more force to move that tennis ball into the court. Now, what did you notice about the arrows? Did you notice that this arrow is 3 times as big as this arrow? And that's because this is indicating this is a stronger force, and this is indicating it's a smaller force. But what's similar between those two? That's right, they're going in the same direction. So both the ping pong ball and the tennis ball have a force acting on them that's moving from the left to the right, sending that ball to the right. Well done. Okay, so we figured out or have been looking at what makes things go, what makes things stop, and forces help things go and help things stop. But how? How does that exactly happen? And what we have to look at is something called friction. Friction is the force, so remember, force is a push or pull, that resists the motion of two surfaces that are touching. So I want you to go ahead and put your hands together just like the guy that we're seeing and rub them together, okay? Fast, faster, faster. All right, you will see that your hands are starting to get warm. Why is that? Well, it's friction. Friction happens because there's microscopic, that means really small, bumps and grooves and ridges in your hands. And as you push your hands together, those surfaces are rubbing against each other, creating friction, and friction thus creates heat. Now, let's look at it in a bigger picture. So here we have two surfaces. You can see that we have microscopic bumps, grooves, hills. And when those two surfaces slide past each other, these are going to bump into each other. They're going to like move against each other and hit each other, and that's called friction. So we're going to look at friction. There's actually 4 types of friction. We have static friction, sliding friction, rolling friction, and fluid friction. And I'm going to post a video later on kind of showing you an actual demonstration of these 4 types of frictions, but for right now we're just learning about it. So here's an introduction to friction types. These are the 4 types. Okay, so we're going to look at static friction. What in the world does that mean? Static friction is the force between the surfaces of 2 objects when they are not moving. So we have this lady coming along and she wants this piece of furniture over here. So she begins pushing on it, trying her best, but this thing is big and heavy. So she's applying 100 N, remember that's newtons, of applied force. But the static friction that's pushing back on that is 100 newtons. So we will look that the applied force is 100 newtons plus the static friction. So whenever we have forces going in opposite directions, we're going to make one of them negative. So the static friction is going to be a negative 100. So when you have 100 plus a negative 100, you get 0. If it's 0, it means it's balanced and things are not moving. No way, no how. So the furniture does not move because of the balance friction. When you have that happening and nothing is moving, something is stable, not going anywhere, that is called static friction. Now, with that in mind, I want you to investigate for me. I want you to look around where you're at or things that you know that aren't moving, because if they're not moving, even though you can't see something pushing against them, there's always gravity or things pushing back. So find 3 things that are not moving, and you will find examples of static friction. All right, pause the video and go find me 3 things. Great, what did you find? I would love to hear about it. Go ahead and put your comments of the things you found in the comments below, especially your favorite. Tell me one favorite thing that you found. Here's what I found around me. I found that I have a pop sitting next to me on the table, not moving. That's an example of static friction. In the bathroom, there's a towel hanging on a towel bar. The towel is not moving, it's just hanging there. That is static friction. We have some bookmarks in a book that are just staying there, they're not moving. That is static friction. Okay, so static friction means things aren't moving, the friction's pushing against it, not happening, not going anywhere. So we're going back to our lady. She still wants to move this big piece of furniture across the floor. She's having troubles. Her friend sees her and says, I can help you out. Okay, so what happens is sliding friction opposes the motion of surfaces sliding past each other. But the furniture is going to move because the combined forces of this lady and her friend is greater than the static friction. So now her friend's joining her. So now it's 200 newtons and it's going to be pushing to the right. And we see that our arrow is bigger against the 80 newtons sliding friction was just going this way. So because they were able to push over that 100 newtons of static friction, it is starting to move, and the sliding friction, once they get it started, is actually going to be less even than the static friction was. So what we have now is we're going to have 200 newtons sliding to the right and 80 newtons sliding to the left. And since it's opposite, we're making that a negative. So now we have 200 newtons plus a negative 80 newtons equals 120 newtons net force. And you'll see that the greater force is going to the right. So they're actually going to be moving this piece of furniture all the way over here. And as long as the furniture is sliding, this sliding friction doesn't change. It's not going to go up or down. It's going to stay the same as long as the surface stays the same. If you changed into carpet or things like that, then the friction would be different. But if it's the same surface and they slide it across it, that 80 newtons will not change. So sliding friction is exactly what it says. It's when something is sliding across another surface. Okay, so what would happen if the furniture here was pushed with more force? Take a minute, pause the video, think about it. Say another friend came and joined them. The guy starts pushing harder than he was before. What will happen to this piece of furniture? Did you say it would speed up? Because that's exactly what would happen. If they applied more force to it, the sliding friction will not change. And so they'll actually start pushing this furniture faster or with more speed. Okay, now we're going to go ahead and look at rolling friction. Rolling friction is the friction when an object, and that's usually a wheel, a ball, something circular, spherical, round, and it rolls over a surface. Makes sense? Rolling friction, something rolls over a surface. Okay. The friction is caused by the deformation or the change of the object and or the surface. So usually when we have tires, the car pushes down here and the tire usually flattens out a little bit. That is creating friction between the tire and the road. So let's look at that in a different way. Here we have the picture of a tire, and this is rolling friction. We have a force on the tire that pushes the tire forward. The tire begins to roll forward, and friction then happens at the bottom here, and the tire ends up flattening out or is deformed a little bit. Now, you're going to say, well, that doesn't happen to everything, but there's usually some deformation that's happening. Either there's heat or scraping that you just can't see. Like if you look at the bottom of a roller skate that you've used over and over and over, if you look at that wheel, you'll see that there's some marks, some grooves, some things like that. Even though you can't see it against the sidewalk, when you take and look at the wheel, you can tell that there has been some rubbing against the wheel and some change that has happened. Okay, now we're going to investigate again. Knowing what rolling friction is, I want you to find 3 examples around you or that you know of. Go ahead and pause the video now and let me know. Awesome. What I'd like you to do is go ahead and tell me your favorite example of rolling friction that you found in the comments below. Here are the 3 that I have found or thought about. The first one, I love to play soccer. And we can see in this first picture that that soccer ball is rolling and eventually it comes to a stop because there is friction between it and the grass. Then we see this lady on her bicycle. And again, rolling friction is happening because of the tire against the surface. And so because of that friction, it's probably why she's working so hard. And lastly, I love amusement parks. And so I put an example of a big Ferris wheel, and there is friction, rolling friction happening right here where this wheel, this circle right here is going around and around on this cylinder. And there is friction happening between this cylinder and the Ferris wheel. That is why they often put things like oil or lubricant there to help create less friction and allow that to turn better. Okay, so we have rolling friction done. Now we're going to move to fluid friction. All right, fluid friction is friction between a surface or object. So in our example here, we have this airplane and a fluid material. What does that mean? Usually when you hear fluid, you think of liquid like water or milk or something like that. But here, fluid doesn't necessarily mean a liquid. It can be a gas, such as the air we breathe in the sky, things like that. So this airplane is actually moving through the air, and that counts as a fluid friction because the air ends up moving around the airplane, the paper airplane that you see. So examples of a fluid material are a gas or liquid, and more commonly to us, it's usually water or air. So this is a great example of fluid friction. So let's go ahead and talk about something real quick. There was air resistance with our paper airplane, but to help you kind of understand what air resistance really is, this happens in the air, not in the water. But air resistance is the name for fluid friction between the surface and the air. So I'm actually going to go back to our previous. So resistance between the fluid and the air. So when the air comes and hits this paper airplane, that's air resistance. When the fluid runs into a surface and is causing that resistance against it. Now for our next one, we can see this parachuter. When the parachuter jumps out and opens his parachute, the air actually catches on the surface of this air parachute and ends up pushing this guy up because the surface area is so big and there is friction between this parachute and the air below it. Okay. Now let's investigate. I want you to find a piece of notebook paper. Actually, I need you to find 2 pieces of notebook paper. Take one, crumple it up into a ball. Leave the other one nice and flat. And just like our friend here, I want you to hold your arms at the same height and drop them both. Which one lands first? Go ahead, since this is an investigation, I want you to do that at least 3 times. So pause the video, go find 2 pieces of paper, crumple one up in a ball, keep one flat, release them from the same height at least 3 different times. Ready, set, go. Welcome back. What did you find? hopefully you found that the crumpled piece of paper fell more quickly than the flat piece of paper. Why did that happen? Well, hopefully you figured out that the flat piece of paper, like the parachute, is going to have more air resistance. It has more surface area, so there's going to be more friction or air resistance against the piece of paper than the one with the crumpled piece of paper. The gravity is going to stay the same. So the only thing that's really changing between those two things is the air resistance. Since this has less surface area, that means there's less air resistance. And you can see that with my smaller arrow versus this, which has more surface area, which means there's a greater friction or air resistance against it, causing the paper to fall more quickly. Well done. Okay, so let's review. We have friction. Friction is in 4 different forms, and friction is a force. Remember that. There's static friction, which means there's no movement, and that happens between 2 surfaces when they're not moving. We have sliding friction, and that's exactly what it says. It's when 2 surfaces are sliding past each other. I have this great picture of this baseball player coming in and sliding for his base. And see, he missed it, but he got it right there. But as he slides, he's actually slowing down because that is friction. Then we have rolling friction, and this happens on objects that obviously roll, and it occurs between the object and the surface they're rolling against, and there's usually a deformation of that surface areas. And lastly, there's fluid friction, which happens in a fluid substance, which again, remember, doesn't necessarily mean liquid. It can be also a gas. And the 2 main ones that we usually look at are water or air. Okay, now that we've reviewed them, we're going to go ahead and check for understanding. What do you remember from what we learned back? So I have this great video here of this girl skateboarding and sliding across this rail. So on point number 1, she is jumping into the air right before she gets to the bar. Point 2, she is sliding across the bar. And then at point 3, her skateboard has landed back to the ground and she is rolling forward. All right, I want you to pause the video. Think about what 3 types of friction you are seeing in this video. Okay, pause it now. Okay, welcome back. What did you say for number 1? What did you say for number 2? What did you say for number 3? Let's see if you got them right. Number 1 was fluid friction. She is in the air and there is air resistance happening against her. Since she is moving this direction, there's air resistance happening this direction and also above her as she starts coming down. At number 2, we have sliding friction. The bottom of the board is sliding across this rail, causing sliding friction. And lastly, she jumps down to the bottom and she is now on the concrete again and rolling away. That is rolling friction. So that's how things start up and slow down. Without friction, we wouldn't have things to push off of and get moving. And without friction, things would never stop. So we have learned our 4 types of friction and why things start and stop. Go ahead and check out some of my other videos, especially the one that actually shows, I'm going to use a toy of my son's to show you how those 4 types of friction actually work and give you a clear example of it. So I look forward to seeing you next time. Have a great day.